Hi, I'm Tom, amateur radio call sign N8FDY. Today we're going to review the Uni UT139S multimeter. It's a 6,000 count meter. Here it is right here. I don't have it in the box because I bought this last year and I don't know where the box is or the manual. I have the electronic copy of the manual, which is all that really counts for me. Anyway, I've been using this and I had high expectations, and maybe they're unrealistic expectations because it was a $70 meter. I got it from TME in Poland. I found out later that you can buy this in the US under the triplet name, and it's I think it, well, I can't remember the model number. I will put it in a lower third, but it's I think it's MM525. I'm not sure, but it's definitely the same meter. And it also came with a thermocouple, which I did not use, and I don't test the temperatures because I don't have a way to really reliably, at least for me, test an accurate temperature. It also came with the plastic leads, which we all know and don't like. So I don't use these leads. And during the testing, I didn't use these leads. So anyway, that's what you get. If you're going for a $70 meter, you probably don't want to buy a $40 set of ProMasters or a $50 set of Flukes TL175. So you know, they're fine. You make sure you clean them off with alcohol because they came with some kind of oily gunk on them that affected how they worked. So I cleaned them off and tried them out. Let's see what else we could say about this meter before we start fooling with it. It is the lowest price meter I've found that is third-party tested. This is tested by ETL for safety. So that's really good, and it makes me confident to think it's pretty safe to use this meter. I still don't use it in category 3 or 4 because I'm not an electrician, and I'm much older and wiser now, and I don't screw with that stuff anymore. But you know, if you do, then at least you know it's good up to 600 volts. Unfortunately, it won't measure anything higher than 600, so if you use a boat anchor, you want to check some voltages on the B+. If it goes over 600, well, this meter starts beeping like crazy, telling you that you're over 600, and it won't really take a reading. But up to 600, it's okay. The voltages, currents, and the resistance are okay. They're kind of middle of the road if you compare these meters, because I'm at the end of the 600 count reviews, I'm going to have a summary video that's going to kind of show you all the meters and where they kind of fit with each other. But it is definitely the cheapest one I'd recommend because it is safety tested, and it's not very good on capacitance, but it tells you that in the manual with the ratings. You know, the 4% plus or minus. You go, well, you know, it's 4%, but you know, if you want to troubleshoot a capacitor and to see if it's anywhere near what it's supposed to be, it should work for that. But let's go over the features of the meter. I already mentioned that it's ETL listed for safety. It's a category 3 600 volts. It's 6,000 counts. The DC accuracy is 0.7% plus 3 least significant digits. It has a bar graph, and it is true RMS. It has a min and max function. It has a relative or delta function. Comes with a thermocouple. It has low ZAC voltage, which is used to find phantom voltages and short them out, and it's more of an electrician thing, so I didn't really mess with that. That's a low-pass filter, which is for use in lowering the AC bandwidth. I mean, the AC bandwidth wasn't that good anyway, but if you're measuring motors that are controlled by variable frequency, they use that to help filter out the noise. It came included with 2 AA batteries, and if you buy the triplet MM525 version, it comes with a 1-year warranty for that. But anyway, let's start with the DC voltages. I do have this at an unusual angle because the way the screen works, it just picked up too much reflection, so I had to lift up the back end a little bit with this pen. So hopefully be all right. So let's put it on DC. Now that it is a reversed screen, so when they talk about backlight, you would think, oh, I'm going to push and hold the hold button to make the backlight come on. Oh, wait a minute. It's dimmer. What happened? Well, unfortunately, that's the way this works. You actually just turned off the backlight. So now I turn it back on, it's brighter. So it really doesn't mess with the background at all. It just makes the numbers brighter and darker. And it will time out on this. So we'll have to watch it because it's really hard to see on the camera when it's in its dim mode. Well, we're going to edit out all the setup, so we're just going to kind of jump from test to test. But anyway, here's the voltages. I did many more voltage tests, and you'll see that on the PDF document, plus I will pull up a chart of that in a minute to show you, but I just want to show you how it works with the voltages changing. And so that's 5 volts. Oops. I always do that. 7.5 volts. 10 volts. So, you know, it's okay in voltage. It's not, it's certainly no Fluke 87 Roman numeral 5, but it's okay. This is the DC voltage table. We went from a millivolt all the way up to 652 volts. The meter cannot read any voltage over 600. It beeps with a warning, and all of them met the specification as stated in the manual. If you look at the specification, the percentage is about in the middle of the road for these type of meters. 6,000 count. There are definitely worse meters and there are definitely better meters. But this gives you an idea of what you're dealing with the voltage. All right. Well, I'm using my arbitrary waveform generator to create 60 hertz voltage. So I discovered that, of course, its output is not exact. You dial in 2 volts, and actually you don't get 2 volts. So on the bench, I'd be using the Keithley to do this, but I don't want to drag it out here. So I'm using my most accurate handheld, and it's pretty big for a handheld, but anyway, the Fluke 289. And so I'm getting as close as 2 volts as I can with the generator, and then you can see what the Unity thinks it is. So that's kind of give you an idea. This is the table of the AC voltages I used to test. The 100 hertz square wave did not really meet specifications on that voltage, so it makes me suspect the true RMS claim. It also couldn't resolve down to 1 millivolt, but from 10 millivolts up, it worked pretty good, and it's about average specifications. Again, not the worst, not the best, but if you're okay with 10 millivolts and above, of course it only goes up to 600 volts. Okay, Well, we're using my little test fixture, which gives me constant current. Didn't come out as even I was hoped, but anyway, this is 0.89 microamps, and you know, it's showing you 1 microamp, which is pretty close. It's most meters are the least accurate, the lower end of the range, and this is definitely the low end of the microamp range. But I just wanted to see how it would work. This is 9.21 microamps, and it shows as 9.2, which is pretty good. This is 99 microamps, and it shows 99.2, so still not too bad. Okay, this is 131.8, and it comes out as 131.9, which is pretty good. Well, now we're measuring 1 milliamp, and it says 1 milliamp. Can't beat that. It is just interesting that the specifications in the manual are nowhere near this good. So the meter performs way above its specifications. The problem is, if you get a meter that doesn't, and you want it to, that doesn't do this good but meets the specifications, the manufacturer won't do anything because they'll say, well, it's in this, it meets the specs as we put them. So this is a sample of 1 meter. You don't know what you're going to get, and your only recourse is to buy a meter that is specified as accurate as you need it, and then if it doesn't meet that accuracy, you can complain to the manufacturer and get warranty repair or get it replaced. I did that. One of the meters I bought for these tests did not come near meeting its accuracies as stated in the manual, and the manufacturer just, well, I'm sure they didn't manufacture it because it was, I've seen this meter in other places, so, but the American representative who's selling it under their brand name, they quickly, within 2 days, had me a new meter, and it met the specs. So they didn't argue, didn't quibble. I just explained what I did and what the measurements came out with, and they, no problem, they sent a replacement meter. So that's kind of why you want to pay attention to the specs in the manual, because I see a lot of reviews where, like this meter is right on. And they go, well, it's, you know, right on. Well, if you look in the specifications, it's got a lot of leeway that it could be before the manufacturer will agree with you that it isn't good enough. So that's why I'm stressing and showing these things out of the manual, and then showing you what the range of acceptable voltages are and currents and resistance based on what the manual says the accuracy is. And it's been my experience that most of these meters are, when I show them to you here, perform much better than what the manual says. So take that for what it's worth. Here we're at 9.96 milliamps, and it shows 10. So it's close. I mean, that's pretty close. It is a little off, but like I said, the specs for this meter, it definitely meets the specs because they're pretty wide. Now we're at 99.4, and this is pretty good. It's at 99.3. You can't beat that. Here's a table of the current measurements. The bright side is that the specification for milliamps and microamps AC current is above average in this group of meters. So that's pretty much the only time this meter's specs stood out from the pack. And of course it met its specifications for all the DC currents, and the specifications for the DC currents are average, middle of the road. So not too bad. I mean, it met all the specs. Now we're going to show you some resistance values. First, we're going to short the leads together to make sure we can decide what resistance these leads have. Takes a while for it to settle. it says 0.2 ohms. So now we're going to use the delta or relative function, which I think is handy to have on a meter. We got to check. Some meters surprisingly don't have that function. And it will zero that out. Now we can go measure the 1 ohm resistor. All right, we have it on the 1 ohm resistor, and this says it's 1.1 ohm. And like I said, it's really difficult for meters to be accurate on the low end of their range. And this, the lowest ohm range on this meter is 600 ohms. So 1 ohm is really low on that range. So that's pretty good. It's better than the specs say it should be. Well, the Keithley says this is a 10.007 resistor. And this guy says it's 10.1. So that's not bad. Again, it's better than what the specifications said it is. Okay, here's a 100.069 resistor, and we got 101. That's still pretty good. This is a 1.001 kilo ohm resistor. And you notice that it says overload or overrange, whatever you want to call the OL. And you go, well, that's mysterious because it's an auto-ranging meter. What's going on here? Well, it turns out that on most meters, when you put it in relative or delta mode, it locks you in to the range you're at when you put it in that mode. So it's still in the 600 ohm range, and it won't move out of that range as long as the delta's on. So we have to turn the delta off, and when we do, it enables auto-ranging again, and now we got 1.000 kilo ohms, which is very good. Like I said, this meter surprises me because it's way better than the specifications claim. The highest resistor I have on this board that this meter can measure is 9.97 mega ohms, and sure enough, 9.97 mega ohms. Here's the resistance values. The source is what the Keithley measured the resistor at. The readings is what the Unity came up with as the value, and they were all within specification. That's why they're all green. The specification is from the manual, and the uncertainty is basically what the specification turns into as an actual value that you would plus or minus to show you what acceptable values are. So, for example, the 100 ohm resistor, which is 100.07 according to the Keithley, is 100 according to the Unity, and it's a 1%, well, it's at least an even digit, plus or minus 2. So that means that you have an uncertainty value of 1.2 ohms. So the value of the resistor, when it's Unity reads it at 100, it could actually be anywhere from 98.85 to 101.28, and they would consider that still within specification. Okay, now we're going to do the continuity test. Well, that's not so good, but I could be the leads. Let's try the leads that came with it. I know I say we're not going to test the leads, but did I remember to bring my probe masters out here with me? No, I didn't remember that, so. Oh, man. That's not very good. I guess I'm going to go get the probe masters, because I should have brought them out here. This is the meter I keep in the shack. This is the Fluke 87 Roman numeral 5. And but anyway, we'll talk about that later. That'll be the second and last review of the 6,000 count series, because I'm doing them by price, and this is the second most expensive 6,000 count meter I have. Needless to say, it didn't come with this case. I don't really care for the flute cases, so I've got this on Amazon. Anyway, that's where I keep one of the sets of the Probe Masters. The best probes go with the best meters. It is latched. It does have that weird stutter. And I'm pretty sure it's not the probes. So, no, I guess most people wouldn't like this continuity. I probably wouldn't like it either. But anyway, that's disappointing. I actually haven't tested the continuity till right now. That is disappointing. Anyway, on to the next test. Now we're going to do the capacitance tests. Now, if you notice, it says it can read 0.000 nanofarads, and that means, it implies that it can read 1 picofarad, because 0.001 nanofarad is 1 picofarad. So, let's see what happens. All right, we have it on a 10 picofarad capacitor, and it shows nothing. So, it can't read 10 picofarads, or 0.010 nanofarads. Can't read it. That's disappointing. Here's 102.56 picofarads, and it still can't read it, because it should be, that's equivalent to 0.1 nanofarad. Nope, that's disappointing. Here is 1.005 nanofarad, and it's reading at 0.787 nanofarads. So that's pretty off. We're definitely not getting the above specification performance in the capacitance range that we were in the voltage and resistance and the current ranges. This is 9.921 nanofarads, and this reads 9.77. And it can't make up its mind on the last digit. Here is 99.51 nanofarads, and this is getting much closer, 99.38. So not too bad. So definitely the lower end is not so good, but it's getting better as we go up. Here is a 1.009 microfarad capacitor, and it's reading 0.999. This is a 944.5 microfarad capacitor, and this says 992.4. Now we come to the capacitance values. Unfortunately, it couldn't read the 10 picofarad or 100 picofarad, and it was off on the 1 nanofarad. And the tolerances, or the specifications, are really wide. 4% plus 10 for anything below, from 10 nanofarads and below. And then the rest of the values, it's 4% plus 5. So as you can see, that's a pretty wide variance. And even though the 1 nanofarad could be anywhere from 0.95 to 1.05, it read 0.667, so it just was way off. The other ones met the specification. Now for some LED measurements, and diodes too. It lights the red LED, it lights the yellow LED, it dimly lights the green LED. Sorry, I don't have any white ones. There's a Schottky diode. There's a small signal diode. There is a rectifier diode. Well, now we'll run through the pros and cons of this meter. Well, the good parts of this meter: it's under $100. It is passed a third-party safety check by ETL. It met all its specifications for DC voltage, current, and resistance measurements. it was above average in AC current in this group, so that is one outstanding thing about this meter. The 600 milliamp fuse is accessible from the battery door. That's very handy. And it's available in the US from Triplet with a 1-year warranty. There are some drawbacks to this meter. It only goes up to 600 volts. The battery life seemed a little short to me. It has below average capacitance specifications, and you have to disassemble the meter to change the 10 amp fuse. Okay, now, what do I think? Well, I had high hopes, but the capacitance range was disappointing. I'm used to the 87.5, so that's kind of accuracy I'd like in my meter, but unfortunately, for $70, you're not going to get it. Now, don't get me wrong. For many cases, the accuracy of this is fine for many projects. So, and for a first meter, it would be fine, as long as you're not going to put much weight in the capacitance measurements, because they are probably the weakest part of the meter. The other thing is it is the cheapest third-party tested for safety meter I found, and it's tested by ETL, and you know, they're recognized by NIST, so it's perfectly fine. And it's nice to have a meter that is safety tested. And I wish those 2 earlier ones we reviewed that were quite economical and seem pretty good. They were not safety tested, so I would recommend you just stay with one that's safety tested. Unfortunately, I have a lot of reviews of ones that aren't, but because they're out there and people are using them, so I want to review them. So yeah, I would say if all you can afford is the $70 and you can find this, especially if you could get the Triplet one version of this instead of the Uni T, because the Triplet one comes with US support, comes with Triplet 1-year warranty. I had to deal with Triplet on a warranty issue, not that meter, but a separate Triplet meter, and they were very cooperative and very quick to replace the meter. So I think it's worth, if you can get a meter that you're happy with, that you can buy through a US dealer representative, it's a good idea because they'll support it. So anyway, I have lots of other reviews coming up, and there is, of course, the written review that is on my GitHub site, and I put a link to it in the description below, so it'll go through every detail and give the recommendations. And at the finale of this 6,000 count meter will be a overview comparison of all of them together. It won't go too deep, but it'll just kind of give the pros and cons and the summary of what I recommend out of the 6,000 count. Then after that, in the fall, we'll have the 10 to 20,000 count meters. And then in the winter, we'll do the 50,000 count meters, which I know is probably esoteric because they're a little expensive, and most people don't need 50,000 count. And if you're going to go 50,000 count, you may want to end up getting a bench meter, but who knows. Anyway, thanks for watching the video, and this is Tom saying 73, and take it easy.